Hello. Yeah. So we started osmotic pressure. We got pi is equals to mRP. This formula we wrote, right? Okay. So pi, I think values also we wrote. What is pi in bar, atmosphere? These values, right? Okay. Next is different types of solutions like isotonic, hypotonic, and hypertonic. Isotonic means both having same concentration. Okay, you have two solutions, and if both have same concentration, that means net flow will be 0. Hypotonic means hypo is less. So one solution is less concentrated, that is called hypotonic. And the one which is which has more concentration is called hypertonic. This is less concentration and this is more concentration. Okay, clear? So isotonic, hypertonic, and hypotonic. Now, most of the time, what happens? They give two solutions, and they are hypotonic with each other. So that time we have to calculate the hypotonic. Whenever it is said, that means both have equimolar. Hypotonic means equimolar concentration. Both have same molarity, and if molarity is same, then pi will be same because R and T are constant. That's why isotonic means they both have same osmotic pressure. This is called isotonic. Hypotonic means it has less osmotic pressure because less concentration. Hyper means more concentration, more osmotic pressure because osmotic pressure is directly proportional to molarity. That is the reason. Okay, clear? Yeah. Then reverse osmosis. Now in osmotic pressure, this is the last concept, the reverse osmosis. Okay, what is reverse osmosis? Now this is a solution, semi-permeable membrane separated, and here the pressure is exerted. Okay, and this is, let's take solvent, and this is, let's take solution. There is a net flow of solvent, liquid from solvent to solution. There is a net flow, and when we apply here osmotic pressure pi, if we are applying some pressure which is equals to pi osmotic pressure, then what happens? Yeah, the flow will stop, right? So this net flow will stop. And if we apply here the pressure which is greater than osmotic pressure, if you are applying some pressure which is greater than osmotic pressure, then what will happen? When this happens, when we are applying pressure which is greater than osmotic pressure, then the liquid from solution will flow to solvent, and this is called reverse osmosis. And where do we use reverse osmosis? Yeah, water purification, RO, right? RO we say, water purifier. So this is reverse osmosis used in the RO water purifier. Clear? Okay. So this is, and this osmotic pressure is taken as, like, most of the time when we have to calculate the mass of unknown substance like proteins or biomolecules, then osmotic pressure is preferred. Okay, and why it is osmotic pressure is preferred? Because this temperature, This is it means in the formula the temperature is written. So temperature we can keep constant. Okay, at room temperature also this can be possible. But boiling point, melting point we have to take. Boiling point means higher temperature, freezing point lower temperature. But this is at any temperature we can calculate. Okay, then the value also, whatever value we get is like, if you are calculating, let's say in Pascal or bar, we get significant amount of value, and exact mass can be calculated. Exact molar mass can be calculated. Okay, and also when you see first RLUP depends upon X2 mole fraction, then molality, and this is molarity, means temperature dependent. And temperature is also given. So whatever increase temperature, decrease, molarity will change. So we will get exact value of molar mass of unknown substance. And that's why this is preferred. Okay, clear? Any doubt? No doubt? Okay, so let's solve one question. I'll give directly because now I have to open this PDF. Okay, till the time everyone is solving the questions, the DPP questions, right? Because I'm not sharing any link to submit. So you guys are not submitting. So just I remember today, I'll be checking now. Okay, those of you are doing, they have to show what they're. Okay, everyone, you brought the no. So where do you solve? Home, different book. Okay, but then everyone is bringing their, like, everyone every day you bring that DPP with you class. This small book you can bring, right? I'm not telling you to bring the big book, but at least the small book DPP you can bring, and that only you can solve it on the regular basis. First you can complete, you can take doubts, and the book also you are doing. So everyone is doing, huh? How many questions you did for solution chapter? 10. That is also not sure, you just saying something like 10, right? You did only 10. Yes, how many you did? 25. But how many you did means not so you remember exactly 10, 30? Okay, how much? So like that, whatever they are saying, something like that you can answer. Okay. Okay. You are not, you get like 50, 30. Yes. So you are doing previous year all? You completed previous year? Okay, all of you? MDG completed? DPP? Okay, so and then the book also. Yes, here. Big one you are doing. So how many? 20? 20, 25. How many you did from the first chapter? 20, 25. Array. Do you think by just solving 25 questions you'll crack NEET? Huh? You think like that? If you think, then you can stick to that. But if you think you need to solve more, then you solve it. Right? Okay, now the question is calculate. See, it is asked in Pascal. Okay, calculate. This is intake question, and it is asked the osmotic pressure we have to calculate in Pascal. So what changes you will make when the pi is asked in Pascal? If pi, you have to calculate. You know the relation between this conversion Pascal to bar, all this? Huh? No? So those of you who don't know, they can just click the photo of the notes, or we can do one thing. Now tomorrow when you come, tomorrow your class? Yeah. Tomorrow chemistry class is at 2 o'clock, right? So what you can do is, you can, tomorrow is Thursday. So what you can do, who came from the beginning? All the classes attended. You attended all the classes. You wrote proper notes.
Me.
Good handwriting. Okay, you think it's good. Okay, someone has to. Someone else can say. Okay, no problem. So when you come at 12, you give your notebook to the coordinator and tell them to scan the first chapter. So how many of you are there from the second chapter onwards? Right? Yeah. Those of you new only, the old were there, I know. That's the best. You attended from the first, right? Second class, the second chapter from the first, right? Right? Okay. So first chapter tomorrow, okay, something is remaining, you take it from someone, okay? And make sure that when you come, I'll tell them anyways, but you also give your notebook to scan. So they'll scan and send the first chapter to all the students. So you'll just refer that. Okay, next. Now the pi is asked in Pascal. Now there are two options you can do. The one is you convert all these units MRT into like SI units, or you calculate that first into bar and then convert. Okay, whatever ways. So what is given? Calculate the osmotic pressure in Pascal exerted by solution prepared by dissolving 1 gram of polymer. 1 gram of polymer. So what is given? 1 gram of polymer is dissolved. W2 is 1 gram. Polymer is dissolved in 450 ml of water. So what is 450 ml? Huh? And it is molarity. V1. V volume. 450 ml. And polymer of molar mass is given. That is M2, which is 18500. 000. At means temperature is given 37 degrees Celsius. And find out the osmotic pressure in Pascal, it is said. So better way is to first find out it in you can find out in bar and then convert into Pascal. I'll tell that. First find out in bar. Don't use atmosphere, in bar. So only what is the change when you write like bar and atmosphere? What change you have to make? MRT. Yes. Abhishek, what change you'll make if it is bar? Yeah. So what is the R value if you are calculating bar? .08?
Sir,
Yeah.
1.0.
1.3.
Yeah, that's in Pascal, right?
No, 8.13.
Okay.
But now the molarity also you have to calculate. That means this 450 ml, you may have to take that into meter cube. So it is more complicated. So what we'll do, we'll just calculate first in bar, and whatever we get, we have to multiply by 10 to the power 5. You get the answer. Calculate. M R is 0.08321 and temperature is 37 degrees Celsius. Calculate the answer. Approximate, you can calculate.
Sir, I'm confused. Like, if it's given in ml, we want it in liter, right?
ml is given, so you have to
Yeah,
first
so
convert it into liter. Yes.
so we can just do given mass by molar mass into 1000 by V, right? For molarity.
Yeah, correct.
So
Molarity
you were
simply you have to
saying we
find out.
have to convert to meter cube.
No. If you are taking this as a SI unit, Pascal, then you have to do everything into SI unit, right? And that's why I'm telling,
Yeah.
calculate the answer pi into bar by simply taking the values, and then whatever you get in bar to Pascal conversion is very easy. Just multiply that by 10 to the power 5. That's it. So it is very easy. So just find out this easy and then just multiply whatever answer you are getting. Just multiply that by 10 to the power 5.
So your R will be 0.83 or 8.3?
0.083.
Yeah.
Yes, done. Hurry. Temperature, you have to take it into Kelvin. Huh? You also took it directly into degree Celsius or what? Arey 37 is 310 beta. Not 300. Arey. Molarity. Molarity. Huh? What is the answer? Big calculations. Arey approximately calculate, Baba. I'll give options, okay? So that because every time I say approximate calculate, but I don't give option, right? I'll give option. 300 Pascal, 30 Pascal, 150 Pascal, D, and C 15 Pascal.
So 300 Pascal.
No, some mistake. What is that mistake? Did you take 0.08321 or 0.8321?
0.83 only I took. I didn't take.
Array, I told 0.08. You wrote that R value only wrong. See, I can just understand what mistake someone made. Even the book is not there. Because you, when you said that time only you told, that's why I got that. Hmm. कहाँ से कहाँ आप पहुंच गए? हाँ, yes. What you are getting? अरे तो तुक्के लगाना तो कोई आपसे ही सीख ले. Yes, here 13. Huh? 13.
So 30 Pascal.
30. So 30 is the answer. Let's calculate now. Pi is equals to m. M 1 by 18500 1000 by 450 R 0.08321 into 310. pi value you have to calculate. So whatever value you get, that will be in bar. So this double triple zero. Array W1 by M2, W2 by M2. What did you do? Reverse. Array. Okay, this zero. Then this two zeros. Then these two zeros cancelled. And then you get okay, this zero again. And this zero cancelled. So you get 0.083 into 31 divided by 185 into 45. Clear? And what I said, whatever value we are getting, that is bar. And how to convert that to Pascal? 10 raised to 5. So I'm just writing 10 raised to 5 here. And then answer will be Pascal. Right? Can we do this? Okay, next. Because we have to calculate the because options we have. So we are just making some changes. So I'm just writing this as just one power I'm taking here. And I'm writing this to be 83. 83 into 31. So I'm just writing 30. I'm making it less. And then this is 50. If I'm increasing this, should be decreased. So how much? 170, 160 you can write 170. Okay. And then this zero cancelled. And then you can do some changes. Or this is 10 to the power 2 remaining. Right? 10 to the power 3 I used here. So 10 to the power 2 is remaining. That means 100 is remaining. And so this 0 and this 0 also cancelled. So here we have 3, 3, 9 and then 1 0 divided by 17 into 5. So 5 ones are 5 fours are then 4 approximately. This is if you say 5, okay, 5 is a 0, then 17 2 and then 11 26 and then 8 remaining 5 something. Yeah, means this is like we are getting approximate, and we did so much of approximation, and closest answer is this 30 Pascal. Clear? So that is the way we have to do. So make whatever you would like to. I increase this, I'm decreasing this. So there is no relation like you may be thinking, but if you practice, we'll get this.
Sir, I
Okay.
was getting 0.0029, then I did into 10 raised to 5 to convert to Pascal, then like it's near to 30. So
Yeah, correct. That is also way. Everyone is clear with this?
sir, but
Yeah.
they will not give like this questions in NEET, right? Like too much big calculations.
Yeah, they can give. This is NCERT in-text question. So this question can come, right? Because there is not one or two things, like not two or more things asked. Only simply they asked the Pascal. They calculate the osmotic pressure in Pascal. That's it. So why can't this come? They ask so many complex question. What to speak of? This is like this is easy thing. They ask even more complex than this. Okay. So till this point, any doubt? No doubt, sure. So let's start now. Van 't Hoff factor or the colligative properties of electrolytes. We have studied till now colligative properties of non-electrolytes. Okay, now what if the colligative because the colligative properties depends upon number of particles. right? You are adding NaCl. But because NaCl is electrolyte, as soon as we put it into the water, it dissociates. So number of particles increased. And if number of particles are increasing, then colligative property will also increase. And if colligative property increases, molar mass will decrease. Yes or no? Because molar mass is inversely proportional to colligative properties, and that decreased molar mass, in this case it is decreasing. In some cases, what happens, there is like, if you take example, acetic acid when added into benzene, if we add 2 moles of acetic acid, they associate and they form one. So number of particles are decreasing. If number of particles decrease, colligative property will decrease. Okay, and if colligative properties are decreasing, then molar mass will increase. And if molar mass increases here, in the other case molar mass decreases. So this decrease or increase in molar mass is called abnormal molar mass. Abnormal molar mass. Abnormal molar mass. So when we calculate the molar mass of NaCl by using colligative properties, we get something else only. Molar mass of NaCl, we get 29.25. How we are getting acetic acid, we get 120. How? Because of this association and dissociation concept. And that's why we get this abnormal molar mass. Okay. And here the concept comes, which is Van Hoff factor. Van Hoff factor, it is I. And I is equals to normal molar mass by abnormal molar mass. This I can be observed colligative properties by theoretical colligative properties. Observed colligative properties by theoretical colligative properties. So there are 2 types of electrolytes, or whenever we are saying electrolytes, in electrolytes, what happens? There are 2 things. One thing is dissociation, the other association. Dissociation and association. Association means number of particles increase, number of particles increase, and dissociation means number of particles decrease.
So you're writing ulta.
With
So
right
dissociation particles will decrease, right?
No, dissociation particles increase, right? Because you add 1 mole of NaCl,
Oh, yeah.
you get 2 moles.
When you were writing dissociation, you said association particles increase. So I got confused.
Really? I said? Oh, really? I said like that? Okay, so dissociation means particles increase. Okay, so dissociation means when NaCl is added into water, it dissociates. So 1 mole of NaCl you add, so number of particles becomes 2, Na plus Cl minus. So this is dissociation. Okay, and when association happens, association means you added 2 particles. Okay, so when you add 2 particles, then 2 particles combine to form 1. So this is association. So number of particles decrease. If number of particles increase, then colligative property increase. Colligative properties increase. And if colligative properties increase, molar mass decrease. And that's why I said that NaCl molar mass will be decreased and it will be 29.25. So this is 29.25. Normal molar mass of NaCl is 58.5. So 58.5 by 29.25 will be 2. So I value is 2. So when there is a dissociation, I value is greater than 1. And when there is association, I value is less than 1. Clear? Association and dissociation is clear. Any doubt? Association, dissociation. Okay. So I value is more than 1. Here I value is less than 1. So abnormal mass will be less than normal. And here abnormal will be more than normal. Okay, this is the same thing. Same here. If I is more, you just imagine, if I is more than 1, that means normal is more, abnormal is less. And if I value is less, abnormal more, normal less. Clear? Getting everyone? Any doubt in this? Yes, sure, no doubt. Okay. Then increase. Okay, write down this also. Colligative properties means what? Colligative properties means properties depends upon number of particles. So if number of particles increasing, colligative properties increase. Write down that number of particles increase, colligative property will increase, molar mass will decrease. Okay. Written? Colligative properties increase. Okay. So there are two types of electrolytes. Electrolytes are of two types. Strong electrolytes and weak electrolytes. So what is strong electrolytes? Dissociate completely. Strong electrolytes means the compounds or the electrolytes which dissociate completely. So there is a complete dissociation. Means strong electrolytes. Strong electrolytes means complete dissociation. They dissociate completely. Means when you have NaCl, NaCl dissociate into Na plus and Cl minus completely. So here I value is equals to, I value is number of particles formed after dissociation is I value. That means tell me for NaCl what will be the value of I? 2. For MgCl2, correct?
3.
3. AlCl3, 4. K, 4. FeCN, 6. Here, what is I value? Now this is also strong electrolyte.
16.
3.
So 4 potassium, 1 iron, 6 carbon, and 6 nitrogen, right? No. Only 6 CN.
So total how much? What is the I value here?
11.
11. Okay. 2. Correct. 5, yeah. Because this is a complex, and complex won't dissociate. It remains as it is. Okay, and that's why only this 4 and this is a 1 ion. This is a complex sphere, and complex sphere is very stable. It won't dissociate. Why I asked this question? Because you should know this coordination compound you already studied, right? And that's why I asked this question. क्या हुआ? नींद आ रहा है? घर जाके सोना है क्या? खाना पीना और सोना. Okay, so there are 5 values. Clear? So here the strong electrolytes I value is very easy. Number of particles equals to I. So it is very easy to calculate the I value for strong electrolyte. But for weak electrolyte, it is quite difficult. So what is it? And also you see this equation, if you just write NaCl becomes Na plus and Cl minus. Okay. In the initial, it is 1 molar. So this is 0, 0. After some time, when dissociate, it becomes 0. And this is 1 molar formed. And I is equals to observed colligative properties by theoretical. So observed colligative properties are 2. 1 plus 1. Why? Because colligative property depends upon number of particles. So particles 2 divided by initial, or the theoretical, we see only 1 added. We don't know what happened after that, but we added 1. So 1. So this is 2. Clear? Everyone is clear with this? Any doubt? No doubt. Okay. Now this is for strong electrolyte. What about for, okay, strong electrolyte examples are salts, strong acids, strong bases. Salts, basically ionic salts, we say. Ionic salts, strong acids and strong bases. Is BaSO4 strong electrolyte? Because BaSO4 we know is precipitate form, right? So is it strong or weak? Yes. Strong or weak then? It is strong. Okay, another question. Is AgCl strong or weak? Have you heard about AgCl? Sparingly soluble salt. So what is it? Strong electrolyte or weak electrolyte? Yes, you only say every time correctly, right? Okay. Yes. What do you think? Correct? Okay. Strong electrolyte. So AgCl, although it is sparingly soluble salt, but whatever is soluble, that will dissociate completely, and that's why it is strong electrolyte. Most students, they make mistake in this too. BaSO4 and AgCl, because in equilibrium chapter we talk about the AgCl so many times, and also BaSO4 comes in inorganic reactions, and students think that because BaSO4 is not that soluble, AgCl is like clearly written sparingly soluble salt, so they think, okay, it is not complete dissociate, but it is strong electrolyte. It will dissociate completely. Maybe the solubility less, but dissociation is completely. Yes.
So in the K4 FeCN6, we only consider 4 potassium and 1 iron, right? Because CN6
Yeah.
cannot.
Yes. Correct. Okay, everyone is clear with this? Okay, now write down for weak electrolytes. Weak electrolytes. Weak electrolytes. What is weak electrolytes? The compounds which dissociate partially. So partial dissociation. And the examples are weak acids, weak bases. etc. Weak acids and weak bases. Okay, you everyone knows strong acid and strong bases. How many are strong acids? How many strong acids do we have? Two. Okay, which one? Okay. Yes. What do you think? Just you speak something that will be correct. Okay. How many? Just तुक्का लगाओ. मतलब ऐसे तुक्का लगाना है बोल रहा हूँ. Okay. Look. अरे ऐसे ही तुमको क्या लग रहा है अंदर से क्या आ रहा है? Okay. हाँ कि 3 into 2 6. Okay, so there are 6 strong acids. You name that strong acid. Okay, strong acids not here. Okay, here strong acids. There are so many strong bases. There are so many strong bases, but strong acids are only 6. Okay, which are the strong acids? Okay, HCl, H2SO4, HNO3, HI, HBr. You know what? HBr and HI, they are even stronger than HCl. HBr and HI, they are stronger than HCl. And then the last is HClO4 perchloric acid. Okay, I'll tell the name. Hydrochloric acid, sulfuric acid, nitric acid. Then this is hydrogen iodide. We don't say iodic acid because iodic acid is HiO3. And this hydrogen bromide, and this is perchloric acid. Perchloric acid. So there are 6 strong acids. Hydrochloric acid is this? No, this is weak. Yeah, it is interesting, right? But that we study even in organic chemistry. That HF is weak. Okay, and HI is the strong. This it is like increases from HCl to HBr strong, HBr to HI very strong. But when you come back, HF weak. Because basically this acidic strength depends upon the stability of conjugate base. So I minus is very stable, but F minus is not that stable, and that's why HF is weak acid. Okay, clear? Okay, here now. Weak electrolytes are this. So when weak electrolytes are dissociated, CH3, so they dissociate partially, right? They dissociate partially, and that's why what we come across one concept called degree of dissociation. Degree of dissociation means how much percentage is dissociated is alpha. Alpha is degree of dissociation, and then the percentage degree means we multiply that by 100. So degree of dissociation is a fraction. Okay, fraction of molecules dissociated. Like we have one mole added, 0.5 dissociated. So 0.5 is its degree of dissociation. So degree of dissociation means it is the fraction of dissociation, fraction value. How much percentage or how much fraction is dissociated is this degree of dissociation. Clear? Everyone is clear with this degree of dissociation? And degree of dissociation and the value for degree of dissociation and I. What is the relation? Let's write down here. CH3 COOH dissociate partially, so that's how equilibrium sign comes. CH3COO minus and H plus. Initial concentration, let's take it is C concentration is added, C moles added. That time this was 0, 0. At equilibrium, some of the molecules are dissociated. So how much dissociated? Alpha. So what we say, C 1 minus alpha. So this alpha is dissociated. So how much remain? So this much. So to understand more correctly, I'll tell an example. You take CH3COOH and let's take it is 20% dissociation. Means 0.2, alpha value is 0.2. Okay, here I am taking 1 molar and 0 and 0. If 20% is the dissociation, so how much remaining? 80 means how many moles will be remaining here? 0.8, right? So what we did? 1 minus alpha. So 1 minus alpha is 0.8. Clear? Everyone is clear? And here there are 2. So in 2, 20% dissociation, how much is remaining? 1 point? Correct? 1.6 remaining. How we did this? 2 into 1 minus alpha, 0.2. And then 2 into 1 minus 0.2 is 0.8. And this is 1.6. So same way, C into 1 minus alpha. Clear? Clear, everyone? So if you just take this, what is C minus C alpha? So C alpha is dissociated, right? So if here 20% dissociation, 0.8 remaining, so how much this will be formed? 0.2, 0.2, right? Because 1 mole gives 1, so 0.2 will give 0.2 and 0.2 here. Mole concept, right? Mole concept or something like that, we similar to we saw. So C alpha, so here also it is C alpha, C alpha. Clear? Everyone is clear with this? And then there is one concept called degree of dissociation or dissociation constant, Ka. Okay, dissociation constant of acid, or Kc, equilibrium constant. Whatever you can write, Kc, Ka, or Kb, whatever you want to write, Ka. And this dissociation constant is equals to concentration of products, C alpha into C alpha, divided by concentration of reactant, C 1 minus alpha. And the C cancelled, you get alpha square C by 1 minus alpha is this value K, dissociation constant. Dissociation constant. Clear? Everyone is clear with this? Dissociation constant. And then to calculate the I value, I is what? I means observed colligative properties upon theoretical, right? Or we can say the colligative properties after dissociation or association upon colligative properties before dissociation or association. I, colligative properties after dissociation, C minus C alpha plus C alpha plus C alpha divided by before dissociation, C, right? C alpha cancelled, and then C common, 1 minus alpha upon C cancel, I is equals to 1 minus alpha. This is the relation we got for this I value. And there is one shortcut we have to remember. Okay. Okay, write down this for this CH3COH. After that, I'll give one shortcut. Done?
Cut this one, this minus.
This is minus and plus. That's why it is cancelling. No, this is plus. Correct. Plus. Okay. The next is weak electrolytes. If it is dissociation, then I is equals to 1 plus n minus 1 alpha, and if it is association, then I is equals to 1 plus 1 by n minus 1 alpha. So this is the relationship between I and alpha. This is the relationship between I and alpha. Now this is shortcut, okay? We have to use every time if it is I given, alpha given, or alpha given, I asked. This simple. N is what? Huh? Number of moles? No. N is number of particles. Number of particles. Number of particles. Means how many particles are dissociated or associated. That is this N value. Clear? Now, why are we studying I value? Because now the formulas of all this colligative properties will change. Like RLVP is equals to I into X2. Delta TB is equals to I into KB into molality. Delta TF is equals to I into KF into molality. Fourth, pi is equals to I into MRT. That means whenever we are calculating colligative properties of electrolytes, we have to put I values. And then only we get the correct answer. Okay? Because particles increased. And particles increase, so we have to put that I value so that you will get the correct answer. So basically, whenever question comes, we have to write this formula. Why? Because I value for non-electrolyte is equals to 1. For non-electrolytes, I is equals to 1. For non-electrolytes, I is equals to 1. And that's why this is the formula which you have to memorize. So for if it is coming non-electrolyte, then I value is 1. If it is coming electrolyte, I value will be something more than 1 or less than 1. And that is the formula we have to use every time. Clear? Yes. So this is how now chapter is finished. So next class, we will solve questions. Okay. And before that, you have to solve some questions, not 10 or 15 or 5 questions. Okay. Solve some 60, 50 questions. See, we have like we do or like we have, I think this is 6th class, 6th lecture of solution. So 6th lecture of solution means weekly we are taking only 4. So weekly you should solve 50 questions. Not weekly, there should be every day 50 questions. So 5 lectures means almost this time you should be saying I have completed the solution chapter. 300 questions. If you are saying 10 and 20, it is nothing. At least minimum you should solve 200 questions. Okay, you complete first of all the previous year, then DPP, or if you want, you can just solve this big book, okay, questions, but solve at least 200 questions. I think I'll share today the link. You submit how many questions you solve. Okay, you can just click the photo and you are sending it for bio, right? Something like that. Same thing, you can share it for chemistry also. Okay, do it, but without doing now, so this chapter also finished. So similarly, chapters will be finished. Now this is 2 chapters. I took little slowly, but after that I won't take very slow. I'll take fast. So that time you won't have much time. So start from now only, studying properly. Okay, so let's stop here therefore.